ask me. I'm terrible at geography.
Philly, Jersey City, boring.
Whatever.
Just kidding. Just kidding.
Yay.
Yeah, good question.
Yeah.
I think it looks like we're settling in here, 100 or so. You ready to get this started?
Let's do it.
Let's start talking. All right, so I'll start. I'm Joe. I'm signing in from Brooklyn, New York. I've been teaching for Manhattan Prep for 7+ years now, and been doing the GRE since 2014. And just some other things I've done for Manhattan Prep. I worked on something that we'll tell you about, something called the GRE Interact, which is a platform we have for delivering GRE content that just was released in the last month.
Cool. Hi, I'm Kat. I am from Boston. I currently am mostly based in New York, but right now I am signing in from Squirrel Island, Maine, which is a little island off the coast of Maine. Yeah, it's foggy and beautiful here right now. Cool. I've been teaching GRE for Manhattan Prep for 3 years. I've been teaching test prep for about 10. And like Joe, I also worked on Interact, which we'll tell you a little bit about later in the night. But for now, tonight, in terms of communicating with all of you, so happy to have so many people here. We're going to be doing 2 things. We're going to be using the chat, which you guys have all seen. I've been sharing where you're from all over the place, which is exciting. We're also going to be doing some polls. So we'll show you what that looks like. Joe will launch a poll. And what I want you guys to do, I want you to pick a letter to tell us why are you taking the GRE? Poll in A, if it's for an MBA. B, if it's for law school. I'm putting these in the chat too. C, if it's for science. D, if it's for social science. And E, if it's for humanities. But you're not going to answer this in the chat. You're going to answer this on the poll that Joe is going to launch right now. So pick A for MBA, B for law school, C for science, D for social science, and E for humanities. Let's find out what all of you are interested in.
All right, looks like we got some interesting stats coming in here. Look at that. We've got 10% MBA, an ever-growing number on the GRE. We've got 3 law school folks. That's pretty new. I think only a couple schools are taking the GRE right now for law schools. The big name there is Harvard is taking the GRE for law schools at the moment. A couple more have been added to the list since. The big winner is science. Yeah, all those science schools require the GRE, and same with the social sciences. And some of the humanities, a lot of them, just because it's grad school, it's weird that, like, you know, a writing school is asking people to take the GRE with all this math on it, but it's just part of a lot of grad school standard requirements. Let me end the poll and share the results. Sorry.
Yeah, science is a big winner. Yay, humanities. I took the GRE for a humanities program, for a writing program. So extra happy to have you all here.
Yeah, good news, Tasha, for the people going for the master's in English stuff. You know, they take a look at it. They often have some bare minimums that they have, but they're not looking to see, like, are you a math genius? You just got to hit some basic minimums there for some of those programs. So make sure you research your program there. Cool. Let's look at. Let's just get this poll warmed up because we're going to use it a few more times. Make sure you know how to use it. So let's talk about pets. What kind of pet? Let's just say what kind of pet do you have, or would you want to have if you could afford / have the space for a pet? Let's go A for
fish.
Fish.
B for bird, C for cat, D for dog, and E for potbelly pig. Yay, all veterinary right. School. But we're going to do it in the poll. We're not going to do it in the chat. So Joe's going to launch the poll.
Boom.
A for fish, B for bird, C for cat, D for dog, E for potbelly pig, or I guess other exciting exotic things like tigers. I don't know if you should have a tiger in your house, but
Nobody.
Joe,
No?
you look concerned.
Yeah,
Yeah, you can only pick one. Yep. Because we're
think
going to use these to answer questions tonight. And for GRE 5 question multiple choice, you can only pick one.
All right, and
ahead,
here we go.
Joe.
Let's see the results. Are you ready?
Dogs. Yay. I have a dog.
I'm just going to say that 17% of people abstained from voting and did not pick a result. It's all that's wrong in the world today. So
Says the person who does not have a pet.
Can't even pick a pet. All right, so here we go. Let's do this. So we got our polls going. Let's dive in. I think you guys are ready. You're ready.
Yeah,
oh, anyone who's we have enough people, 259 now. I'm just wondering, I'm curious, is there anyone in here who is celebrating their birthday today? Anyone? Not soon.
Well, we got us soon.
Tomorrow.
Tomorrow, nice. Happy day in advance birthday, Katie.
Fellow Leos.
Yay.
Okay, well, Katie, if you're back here tomorrow, we'll celebrate with you tomorrow.
Yep. Same for you, Gabriella.
All right, cool. Here we go. I'm gonna share something with you. So here's what's on the agenda today. We've got intros check out of the way here. Excuse me, just Kat, you seeing this right now? Just making
I'm
sure
seeing it. It looks good. I'm going to put a big check mark next to intros. We've done it. We are introduced.
The theme today is hard stuff made easy, or tough topics made easy. And we've got some tough topics, and maybe a better title would be tough topics made easier. There's any test prep folks who tell you that, like, oh, here's this one trick and now it's so easy, is I think is tricking you a little bit. The reality is this is a sophisticated enough test that there's not some little trick you learn that makes things easy. Probably the trick itself is going to require a fair amount of work to understand when and how to use it exactly. But that said, the other theme is a lot of those alternative ways we're going to do it are different in that you have a certain way of working problems, especially in math, where you translate and solve equations, and we automatically think that that's what this test is going to be all about. And we're going to see in a theme really for the next 30 days that that's not really how that test operates. And we'll see that tonight, that there's a standard way to do it. And if you can do it that way in a given amount of time, great. But often that's not the best way to do it. And if you are one-dimensional and can only solve it in a traditional method, you're going to run into problems. So we're going to show you some cool other ways of approaching. The topic we picked tonight is weighted averages, which I think is a classic, fits into that mold.
Yep. And then on the verbal side, we're going to look at the reading comp argument questions, which are probably the most math-like part of reading, but also a problem type that can be quite tricky if you do it in sort of the traditional proper way. But if you learn some of the common patterns and things to expect from these questions, there are ways to make these a little faster, a little less effortful. So we're going to look at that in the second part of tonight's session. In between, we'll tell you guys a little bit about other things that you can do to continue to prepare. You guys are getting off to a great start. You're here doing this session, which is awesome. And if you want to go further, we'll point you towards some resources that might help. And yes, this is being recorded. You guys will notice in addition to the chat, there is also a Q&A feature. You are totally welcome to ask questions there, but because we have a big group and we have a ton to do, we may or may not get to answer that many questions. So feel free to raise questions. We'll get to what we can. If we don't get to your question, don't feel bad. It's just the constraints of the time and the format.
Yeah, we'll give you some contact information for, we have a whole student services department who can answer a lot of basic questions for you. By the way, really exciting, guys. I think we are very good chance that this is the largest group studying GRE anywhere in the world right now. So congratulations, everybody. Exciting moment.
Yay. Definitely the biggest class we've gotten to teach. This is pretty cool.
Cool. Here we go. So weighted averages. Let me clear that. So we're gonna spin this up here. You got to understand how to take an average first, and we're gonna start with basic averages. Make sure you get that. But if you feel like, hey, I already know how to take an average, why are we wasting time with that? Stay tuned, because really some cool tricks we'll show you there, even within a standard average problems. There's some nice shortcuts and ideas. And then we'll move up into this concept of the weighted average and give you some advanced techniques to solve them quickly. So in pretty much all of these, you'll notice a bit of a pattern of there's this standard way that you probably would have thought to try to solve it that may work anywhere from okay to be pretty tough and computationally heavy. And then there's another way where there's just using a more cerebral way of thinking about it, you can solve it more quickly. They're both valuable, so look to build on both strategies. If you have none right now and you want to get into one right today, that's great. If you feel like you already got one down today, then let's see if we can push for the second one. Here we go. Here's your average formulas. So first one, we've got our average is the sum over number of terms. That's the one that basically everybody, that's the one we learned in high school. Add everything up, divide by the number of terms, and that will give you your average. If only the test was that easy.
But something that could also help is to rearrange this formula and instead think of the sum as the product of the average and the number of terms. A little adjustment to that standard format, but we're actually going to see that be quite powerful and quite helpful tonight.
Yeah, just a couple of things about that. That second form of it, just recognize it's not in a fractional mode. Recognize as well, you can use it to get in the mindset of I'm solving for a sum, which is often what the GRE is going to ask you to do. It's not going to say what's the average. It's going to, in some way or another, want to know what the sum is. Two big pieces of averages to start thinking about is you have an average. When you're doing average problems, you'll get averages. And I think the other thing is just how many of the things are behind that average. Are there 10 kids with an average score of 80? Are there 20 kids with an average score of 80? So consider both of those. Those are two concepts to be thinking about when you get an average problem. Here we go. So let's start this off. Pop quiz. It's time to do math. Couple problems for you. Go ahead and try them both. Give you a minute for the two of them.
You can chat your answers in if you'd like. Yep, go ahead. If you're getting the answers, keep them coming in the chat.
All right, I feel like we're coming to some consensus here.
Yeah, nice. Looking good. I like it. So I'm seeing a lot of right answers. For this first one, we get 5. So we add up our numbers. And I'm going to write in 0, even though it's not going to change that sum, just so I remember that I have 5 terms. One of my big things with GRE Quant is writing down a lot. It saves me from small errors. And it actually keeps you from getting tired too. So it's a good thing to push yourself to do if it's not your innate habit. Divide that by 5, and I get 5, which looks like lots of you are getting. Awesome.
So I'm going to just get you thinking about something else here for this kind of problem. So notice our average ended up being 5. I just want to show you a property of averages that may appear later. Hint, hint. Our average was 5. Let's just, sorry guys. Our average was 5. So let's just see how our other numbers related to that. So we had 0, 4, 5, 7, and 9. 0 was 5 below it. 4 was 1 below it. So in total, we're 6 below our average. 7 was 2 above it. 5 was spot on, so no different. And 9 was 4 above it. So notice combined, these were 6 above and 6 below, and 5 was spot on. In total, our difference from the average of all of those little entities was 0. So this is just something to be aware of with averages. Your net difference from that average is going to be 0. We'll look at that more later.
It's going to be helpful. It's going to be cool. Second one, so this is where we use our rearranged formula, right? So I know that if I have the average times the number of items or terms, I'm going to get the sum. I often like to organize my work into a chart. We're going to see that later, my theme of organizing things. So I know 7 is the number of gifts, $20 is the average, and I get $140, as so many of you did.
And just another thing to note there with this, when you're thinking about an average, how do you think about it? When I see there's an average of 20 for 7 gifts, there's a lot of different ways you could average out to 20. One way that can be helpful and just an easy case to think about, and is an okay case to think about, is so there's 7 gifts that cost $20 a piece. You're allowed to imagine it that way, and that can make some of them a little easier to think through on a more complex problem. So you could think of that as 7 gifts that each cost $20 if you want. All right. So let's move forward here. Let's step it up. A little tougher problem for you. Give you 1 minute to take a crack at this one. Good luck.
All right, cool. I'm seeing lots of nice work. Awesome. So this is an example of where I might set up a chart. And these charts, I think, are going to become increasingly helpful as we get into more and more complicated problems. So let's see. I'm going to set it up. I'm going to say, okay, what's my average and my number and my sum? So, and I have sort of my first situation and my second. So for my first situation, I have 5 exams and I can just add those together, right? Add them up. Oh, this already feels like a lot of work. So I add those up and I get 390. Now for my second, I know that the average I'm looking for is 80. And I have 6 exams, so multiply those together and I get 480. So I see, okay, I need to make up the difference in that sum. I do 480 minus 390. I might do some of this on my calculator. I might do some combination of calculator on a paper, and I get 90, as so many of you did.
Okay, so I will say, don't feel bad if you didn't get there by the time we started this explanation. And also, we're kind of moving through this explanation. Let me try that again. We're moving through this explanation a little bit quickly because I want to show you something else cool here. So this was definitely like Kat's high school math teacher is nodding with approval. Really
and my
good.
high school math teacher was never nodding with approval at me. So I'm also proof if you don't like math, you can get there.
Super good organization and just really just using that average times number of terms equals sum formula. Did anyone do it in another way? Because there is a faster way here. This was a lot.
Yeah, I did not enjoy writing all that
You
down.
could use algebra the way you showed. That's it. That's it.
Yeah.
The net difference. If you do the net difference here, we know the average is 80. And we then know that our net difference from 80's got to be 0. So we've got 70, 75, 78, 82, 85, and some unknown that we don't know. So let's look at these. This one's 5 below. This one's 10 below. This one's 2 below. This one's 2 above the average. And this one's 5 above the average. So where are we at? What are we seeing now? Well, the -5 and +5 are canceling. The -2 and +2 are canceling. So right now we're sitting 10 below. So to come out to an average of 80, we need a 10 above. That would be 90, which is 10 above. So that's I did this pretty thoroughly. I probably wouldn't have to write all that down if I were doing this on test day. This is just to show it. But look at the math we're doing here. We're adding 2s and 5s rather than adding 85s and 75s and 78s and multiplying bunch of things. Math is cool. Wow, that didn't take much to convince Alan after all this time of doing math. One cool problem and he's in.
I like it.
Love it. All right, cool. So just to bring that home, this is what I want you guys to take away from this. What is that this shortcut method is the net difference from the average must be 0. You should look to use that when you know what the average is. If they've told you here's what the average is, start pushing forward with, okay, then how do things differ from that average? I know that needs to come out to 0. Always, any group of numbers, the net difference from the average must be 0. It doesn't work on every problem. I'd say it's in terms of it might not be a useful approach in every problem, but it's always true. Yeah. It'd be a useful approach on problems where you know the average, or it's more likely to be useful.
Yeah.
Cool.
We're going to see it again too. We're going to see some cool applications of it, hopefully.
Yeah, so keep it in the back of your mind. Let's move forward. I want you guys just to think about this for a second. Keep thinking about it. Give you a few seconds. Think about what the answer would be. Don't type it in just yet. Okay. Let's do this. Go ahead and type in, what do you think is the average of the two classes?
Yeah. 25 is so tempting. It's so tempting, right? We have some dissenters, but I'm seeing, and it makes sense, right? Because I have 20 and then I have 30, and I could just find the average of those averages. Oh, divide by 2, and I get 25.
Cool. Yeah, I think that all right. The dissenters are now starting to get a little louder. Yeah.
Yeah.
Think about if you're not seeing this yet. So they're correct. We actually don't know. So sorry, guys. This was total setup. There is no answer to this. We don't know the average. We do know something. We know the average has to be between 20 and 30. We can't have a bunch of 20 and 30-year-olds. Remember, we can think of a group with an average age of 20 as a bunch of 20-year-olds. So we can't have a bunch of 20-year-olds and a bunch of 30-year-olds and average 35. That can't happen. So we know we're between 20 and 30, but that's all we know. Just think if you had like 100 20-year-olds and one 30-year-old.
That's already like my biggest nightmare of a party right
there. I hear that. But when I was 20, this was my biggest nightmare of a party. Funny how that happens.
I know, we're getting old.
So think about what would that average. If you were at a party with 120-year-olds and one 30-year-old, would you be like, yeah, average age was about 25? No, you wouldn't. And same if you're at a party with this 130-year-olds and this one 20-year-old showed up, you wouldn't be like, well, it's an average age of 25 in here. So this is the big lesson here. We can't just average averages. So when you have multiple little averages and you're getting the big average, don't just average the little averages. It depends on how much weight there is, how many of them there are. So that's the weight when we talk about weighted averages. Remember that average formulas are average times number of terms. That number of them is their weight. And the more weight you have, the closer you'll be to your average. So in that first case, we'd be closer to 20. In that second case, we'd be closer to 30. Let's go ahead and look at one where I tell you how many and actually go for the solution. See if we can do this. And I'll tell you there's, again, like a high school teacher nodding with approval way and maybe a better way for the GRE way? It wouldn't be quite as tricky as the one I did, Sophia. That was the question. It would trick questions like that. No, they wouldn't set you up that much. Like you think there should be an answer and there isn't. It's a little
There'd
more.
usually be like an answer that said can't be determined, or
Yeah.
you'd have some hint that that was a possibility.
Exactly. Okay, cool. Take a minute and a half and see if you can solve this one. So I see some answers coming. I'll ask you guys to hold for one more minute before you enter your answers, the rest of you.
All right, so I'm really into making my high school math teacher retroactively actually proud of me. So I'm going to show us that table again. Just like what's the computationally intensive but nice, pretty way to do this problem. So I'm going to set up I'm not going to set up that many tables. That was a mistake. I'm going to set up this table and I know, okay, have two groups. And I'm gonna actually, it needs to have 3 because I know I'm gonna have each class individually and then I'm gonna have the 2 classes together. All right. And so then I'm gonna put at the top to remind myself of my formula, average times number equals sum. Okay. So I know I have one classroom and this classroom has 12 students and the average age is 20. Then I go on to the next classroom. And I like to do word problems like this, sort of piece by piece translating so I don't get overwhelmed by all the information, particularly as they get longer. And then I'd say, okay, class 2, their average is 30 and they have 48 students. Nice. So, 48. That's why I write everything down so I can spot my tendency to make small errors. And then I know I have 1 and 2 together. So right away I see, okay, cool. I can sum up the number, right? I can find the total number. I add those together and I get 60. I know also I can't just add the averages, right? Because if I get 50 if I added them together, and that doesn't make any sense. Like we saw that with our previous example. I know the average has to be between 20 and 30. So now I break out my calculator and I do 20 times 12 and get 240. And I do 30 times 48 and I get 1140. I did this all in advance, so you wouldn't get to see the beauty of me making small math errors. And I'd say, okay, I can add those sums together, right? Because that I can pool the sum of one group with the sum of the other group, and I get 1680. So I know my combined average is going to be the average times 60, and I can divide. Oh, I did make a small math error. Yay. So I can divide 1440 by 60. See, that's my Achilles heel.
The second row is the 1440. That was I missed that too.
Yeah. Yikes. 1440. Yeah, I am a good poster child for keeping your scratch work organized, but I do come out to 28. And that's how I would use let me rewrite that so it's not so awful. That's how I would use the table. Maybe slightly slower walkthrough of that table for people who had questions about it. So I can get there with this method, but just as you can see, there's a lot of opportunity to make mistakes.
Nice catch, by the way, Ivy, Avery, Jonas, and Emin. 3 points on your GRE for you. Way to go. Yeah, here's the thing. Here's what you should be noticing is it's actually, there's a lot of moves we had to make here, and none of them were particularly crazy hard, but every step we have to take is another opportunity to have a little careless error. We're all human, and it's going to happen. So methods like this, if you can do them, that's great. It's good to have a way to solve a problem, but don't be content just because you have a way to do a problem. A big theme on getting better in this test is developing a flexibility and a range of approaches. So let's talk about another way to think about this. Yeah, Michelle, you're getting into now this idea of weighted averages. I'm going to show you something. I'm going to do even a little less calculation than that. So here's this way I want us to start thinking about weighted averages. Not just a way to do the math or an equation to memorize, but just a visualization. So this is something I'd actually write down when I'm solving these. Is what are my averages? That's the first thing I have to determine. We're averaging ages. And what we have are our two endpoints that we're averaging. On the one side, we have the 20-year-olds. And on the other side, we have our 30-year-olds. And then we're trying to figure out where we're going to end up. Now, can someone tell me, why don't we just chat into the window, where are we going to be closer to based on what, just without doing any calculations, where are we going to be closer to? Yeah, and that's because looking up here, the how many part, 30 is heavier. And so the way I visualize that is if I want this to be a balanced teeter-totter, where would that fulcrum need to be? If 30 is 30 is the dad and 20 is his kid, where does the fulcrum need to be? Since 30 is heavier, we need to put it somewhere closer to 30. Now, 25 is the dead center. So immediately I know I'm between 25 and 30. So out goes 22, out goes 25, out goes 50. And then between 26 and 28, this is where we can, you can't know 100% if you haven't thought about this a bunch or done a little bit of calculation, but we can say, how much heavier is 30? Is it just a few more 30-year-olds than 20-year-olds, or a lot more 30-year-olds than 20-year-olds? Yes, there's a lot of them, 4 times more of them. And we'll actually talk more about that in a bit because we can do the full calculation. But yeah, 26 is too close to center. So we'd be like, we could, in about 30 seconds, be 90% certain on this problem that it's 28.
I saw a lot of people were really quick on the answer with this. Is that how you thought about it? Natasha, it's sort of like a very educated guess, and guessing is actually often a really good strategy on the GRE. It's really likely you're going to have to guess, or you should guess on at least a couple problems in each of the sections. And if you can make a really smart, highly likely guess like this, that's a very good bet.
And I'll just further that. There's this sense of like guessing is like a half failure, but there's a lot of problems like this where it really, I don't feel like I'm guessing when I pick 28. Keep doing that. I don't feel like I'm guessing when I pick 28 here. There's a sense of that's not an accident that they throughout the test set up answer choices in such a way that you can eliminate a lot, and sometimes all of them, with a high degree of confidence. And you should be ready to use that and not think it's like, oh, that was a half failure. It's more than an educated guess. It's like I think I know the answer here. I just didn't do the full math calculation, and that's okay. All right, let's so here's where we are. I want you guys to see this idea of the overall average there. What we ended up doing was that it's the total sum over the total number of terms. And as you saw, the way Kat envisioned it there was rearranged as the overall average times the total number of terms equals the total sum. So be on the lookout for that when you get, and we're going to start pushing that weighted average concept when you get more than one average. Basically an average of averages, and a way you'll often see that is in a mixture where you're mixing two fluids up. All right, here's where things get really cool. try this problem out. There's more than one way to do it, as usual. Don't jump in with the answer quickly, but wait until we call out for the answer. Actually, I'm going to put up a poll. Why don't you pull in your answer when you're ready? So here's something I'm going to ask you to do. Right now we have 25% of people with answers in. If you're trying to do some big calculation, take a step back, try and just get a feel for this information and see if you can make a best guess on this one, just like we were talking about before. We'll give you 30 seconds to do that, and then we're going to talk about it. And I want to see all answers in within the next 30 seconds. So take your best guess, even if you're still clueless at that time. All right. I'm going to publish the poll for you all to see. This is where we're sitting. Mostly B's, fair number of A's and some C's. So, Kat, you want to?
Yeah, I'm really into the long, drawn-out solutions in which I'll be likely to make mistakes today.
Who was your math teacher, Mr.? I think I had actually Mr. Wilson was my math teacher.
Oh God,
are you out there, Mr. Wilson?
Miss Lamotte, she was one of my math teachers. Mr. Parrish, might have slept a lot in that one though. Yikes. All right, so if I'm going to do this out the long way, all right, so I have my average times number equals sum. And I know I'm thinking about the combined average. So I know I'm sort of shooting for total sum over total number. That's kind of my goal here. So, all right, let's see. I have town X and I see, okay, here the average salary is 55,000 and it's 66,000. And I could take out those zeros if I wanted to make it a little bit easier. I'll keep them in just for the joy of writing a lot on the screen, 45,000. And I would get sums for those. I would add up those sums and I would do sort of this. I'm not going to write this all out because it's going to end badly. But basically, I would continue using the calculation, using this formula, and I would end up with 49.75, which actually comes out to, if I add the zeros back in, this is my result. So if this were not a multiple choice question, if this were a text entry question, I would have to do this. However, I really don't want to do this here. This is not, I see right away, this is not worth it. And I am going to try and find a better way. So Joe, can I try the weighted averages on this one? Save myself.
I think you're ready, Kat.
I think I'm ready too. I think it's time. I think after my great showing with my calculations earlier, I think I really need to embrace this new method for everybody's sake. Cool. So I'd say, okay, I have a 55. So here it's important to keep the averages, what's an average and what's a number straight. So I sometimes think of it, I put the average down here. That's sort of what the axis is. And then I'm going to deal with the number itself, like up here in terms of the weight. So, and then I'm going to put my 45 down here. And then I actually like to kind of draw the weights. So let's see, town X, which is up here. Town X this is 50, has 66,000. And town Y down here has more. Let's actually make that more visibly more, 73. So if I'm thinking about my teeter-totter, I see right here, it's going to be closer. It's going to get pulled closer to this. Like it's going to balance. It's going to tip toward that. So it's going to be closer to 45. Now, how does closer to 45 compare to 50? What's the significance of 50? Well, 50 is the halfway point. So 50 is where I would be if I had equal numbers of people in both towns, but I don't have equal numbers. I have more people in that 73,000, in that 45,000, that lower bracket. So I know that the average salary of both towns has to be less than that 50,000. So I can answer this question fairly quickly without having to do all that calculation if I use this balance, this method. And I would actually draw out this balance or some form of it on my paper. I'm not doing all this work in my head on test day. So it's still an on paper method. And I think Rebecca just raised an interesting point. Definitely at first, this trick and some of the other tricks we're going to talk about tonight may not feel like they're instantly faster, but with practice and time, they often become, if not faster, then mentally less of a load.
Yeah, and just to push on that, Rebecca, like Kat's justifying every point along the way right now, just to help try to explain it and make it clear. The reality of what this would look like on test day, as far as like if you've practiced this, is maybe even this thing eventually is in your head, but at most you're drawing that out and you can quickly say, this is more like 30 seconds of like, okay, we have 45K, 55K, and we have more people over here. So we'll be somewhere over here, more than 50K, and you're done. That's it. That's the whole thing. If we had just done that right now, you'd be like, wait, hold on, explain that again. So there's like a sense of when you're first explaining or thinking about these things, there's going to be a lot of little thoughts that you have to have that are a little clunky to have. And that's what comes with the practice, is those become smooth, quick thoughts. And suddenly you're getting there in 30 seconds. Basically, the fastest version of this is really fast. The fastest version of that first way Kat solved this is not much faster than the way Kat solved it. It's like you have to do all those calculations no matter what.
And if you're like me, there's a really good chance you'll make a mistake in there. And I'm much less likely to make a mistake here.
Oop. And yeah, I put that circle on the wrong side, guys. That should be, sorry. There are more people in the 45K town. So we're somewhere over here. Sorry about that. Yes.
Yeah, one thing to point out about this, I just am putting the answer here. So the answer here is B, quantity B is greater. We'll talk about this format, quantitative comparison, a lot more tomorrow night. There's a lot of particular tricks for it. But one thing that's good to note is quantity B is a number. And this strategy only works here because of the number that quantity B is. So because quantity B is 50,000 is that midway point, we can use this strategy. This is actually a strategy we can use for a lot of QC, quantitative comparison questions. This idea of what is the number in quantity B, how is that relevant? Talk about it tomorrow night. But it's a good preview of that. And it is important to note, if quantity B were not 50,000, we wouldn't be able to use the strategy in the same way.
Yeah, good, Govind. Yeah, if you had the same number of citizens on both sides, we would have ended up at 50K. But we have more in the 45K town, so we'll end up closer to 45K. So we're going to push on this now. So this is the basic idea of weighted averages. So just to get some big points there, what are the averages? That's what you need to figure out first. And here we're averaging their salaries. And then we have the number of citizens, that's how many, and that's our weight. So remember that, and we're going to push forward with this. Right now we've established we can figure out which of those averages we should be closer to, but there's actually more you can do with this that can honestly save a lot of time. I don't think we're going to necessarily make the case. I think if for one of the other units, if you can do one and you're happy with it, great. I think the point I would make is you should push for flexibility. That's awesome if you have one that you're comfortable with. Think about which has the fastest possible outcome though, and push to make sure you know that as well. Don't be content with just one way. They're both okay ways. If you can solve a problem in like a minute and a half, it's okay. That's good. All right. So you can use these weighted averages concepts to approach a lot of these problems. Now let's talk about some advanced weighted averages techniques. So here we go. Here's a problem. I'd like you just to do your best, think about this and make a best guess. I'm going to give you only 45 seconds to do this. Ready, set, go. I'm going to give you a poll to give me your best guess. Okay, we got 15 seconds left. Hurry up, make that best guess. Look at that. This is a problem that would stump a lot of people, and we've got almost half the class getting it right in under a minute.
Yay.
That's amazing. I've just closed the poll instead of sharing it with everyone. Well, just take my word for it. So a lot of people were guessing. Okay, well, let me ask this. Let's see. Get your fingers on your keyboards here. What were we averaging here? What's the quantity that we're averaging? I guess like what units? What's the thing? The dollar amounts. Yeah, that's what I'm looking for. Not the clearest question, but that's what I mean. Is like we need to determine what are we averaging, and what's the weight. So here we're averaging the dollars per glass, and what's the weight on this one? What determines which average will be closer to? So the price is what we're averaging. And the number of glasses is the weight. Cool. So that's how this thing is operating. So this is what our teeter-totter is going to look like. Remember, our averages go on either end of the teeter-totter. So we have over here, we say Monday, $8, and Tuesday, $11. And they tell us on this one the overall average. And when they do that, this is going to open up another possibility. So we know we're closer to this with $10. So immediately, if we're just in guess mode, which day did we sell more on, Monday or Tuesday? Boom. Boom, we had to, because okay, good. I think you guys are getting this weighted average thing. So we have our overall averages closer to Tuesday. And what does that narrow our answers down to? If we know we sold more on Tuesday, think about what they're asking us for. Cool. Yeah, D or E, more than a half. because they're saying how many are sold on Tuesday, and we know it's more than a half. So it's got to be D or E. That said, it's kind of hard. They're pretty close to each other, so it's hard to distinguish should it be D or E. So here we go. Let me move this down a little bit. Oop, I forgot one. Oop. Come with me. There we go. There's the T. So let me show you how to actually figure this out. So we'd have a pretty good guess between D and E, but check this out. We can actually get the how many part when we know all these ratios, when we know all the averages. We can get the how many part. Here's how. It has to do with exactly what we're talking about, how far the averages, the overall averages from the individual ones. So if we look over here, it's 10 is 2 away from 8. And 1 away from this. So the average is twice as close to Tuesday as it is to Monday. What that means is that there were twice as many glasses sold on Tuesday as there were on Monday. Crazy. And so if you want to just get that mechanical way to get the ratio, just remember if you have twice as many sold on Tuesday, the distance away from Tuesday becomes twice as big. So because of that, just remember you have to, when you're writing your little ratio up here, you have to flip the difference. So it becomes 1 to 2. And at this one, we're talking about the proportion of all glasses. We want to finish our ratio with our total. So 1 to 2 to 3. So all it is, guys, get those differences from the averages and flip them. That's it. And there we go. 1/3 are sold on Monday, 2/3 are sold on Tuesday. The one Monday to Tuesday would be 1 to 2. If you're like, oh my gosh, that's a lot, well, just recognize on a very, very hard problem with just the basic weighted average concept, you can get a 50-50 shot in under a minute. Takes one step beyond that to get to the rest of the way.
And a good way to remember, I think, the flip is just at the very end of the problem, do a quick common sense check. Like, does that fraction make sense? Does 2/3 make sense? Is it saying there's more sold on Tuesday? Yes, good, got it. It's a good last little step to add into a lot of word problems.
Right, so the answer is, just so you guys are seeing that, what fraction are sold on Tuesday? Well, it's 2 to 3, so 2/3. The answer is D. And just to answer that question of like, why do we flip them? I'll give you 2 reasons. One is it doesn't matter, just do it. That's at some point, just accept it. The best explanation I can give is that, again, it's like, I think the way to make sense of it in your head is that as Tuesday's getting bigger, can you see my spotlight here? As Tuesday gets bigger, the average will move closer to Tuesday, and this number gets bigger. So this is the number that corresponds to how much of Tuesday there is. When there's a lot of Tuesday, the number opposite gets larger. So that's why you end up flipping it. You could have plugged in the numbers, but you would have had, yes, that would be one way to do it. But now you're creating variables, and you're going to be making a math teacher proud somewhere and taking a long time to do it. All right, here we go. We're going to try another similar one. Give this one a shot. Same thing. See if you can do step 1, which is to like get some eliminations, get a decent guess. And if you get that, see if you can go beyond there and use the technique we just talked about. If you're real brave, you can try and make a math teacher proud. Okay.
All right. I'm gonna do this one. Yay.
Let me show you guys the poll real quick, because this is interesting. Tell me what you think is going on here. We got a lot of A's and D's. What's happening? Yeah.
Yeah,
Someone,
Sophie, Sunny.
some people had a Williamsburg special before they did the problem. I think that's what happened.
Also, this sounds like the worst drink ever. I'm not on board.
Too many hipsters and
Yeah.
their PBRs and JDs. Okay, cool. Let's see it.
All right. I'm excited to do this because this method is cool to me. So all right, let's look at how it works. So I have my PBR down here at 5%, and I have my JD a little better up here. Oh, that should go up there, up here at 25%. Nice. And I know my average is going to be 10%. All right, so I think about the distance that each of these is from the average. So here I see it's 5, and here I see it is going to be 15. So now I'm looking, here I have PBR over here, JD over here, but I flip these. I don't forget the flip because I'm looking for PBR to JD, so I get 15 to 5. So if I have a ratio of 15 parts to 5 parts, it means in total I have 20 parts. So that's my total. Nice trick for ratios too, to always write in that total. And I say, okay, PBR to total 15 over 20. And that gives me 3 over 4. Yay. Don't forget the flip.
For speaking of those who forgot to flip, it's an easy mistake to make, and just I think a good upfront thing to do is have your early kind of sanity check. Just if we got our teeter-totter set up at the beginning, what do we know we should have more of, PBR or JD? Remember, our PBR is 5% alcohol and our JD is 25% alcohol. And our overall average is 10%. So we should have more PBR because our average is closer to PBR. And so that right there narrows it down to C, D, and E. And so then if after you do your fancy calculation, you end up with A, 1/4, you know something's gone wrong. The 2 5s there are because one is PBR's percentage is 5%. The other 5 down here is the distance between 5% and 10%. Remember, we want those distances. So just a coincidence that they both ended up being 5. Yeah, the 5 is the change between these, and this 15 is the change between 10 and 25%. Yeah, and so here's how this one fits in. It works on problems you get more than one average, and in a classic problem type that fits this mold is our mixture problems. Because when you have mixtures, it's really just another way of thinking about an average. It's what percent of your mixture are you, and how much of the mixture is there. So this is another average problem in disguise. So think weighted averages when you see more than one average, or when you see mixtures. All right, guys, we have a grand finale. There are at least 3 ways to do this problem. Pick whichever you like. If you want to make Mr. Sanderson proud, go do that. There's differences from the average, remember, and you have these weighted average concepts. See if you can put those to good use. Here we go. Try this one. Okay, here we go. I gave you guys a bit of time. I wanted to give you a chance to flesh this one out. Another really tough problem that we like I said, this isn't easy problems made easy. This is hard problems made easy. And as I said, easier. These are still really tough problems. So I'm so bad at showing you guys the poll results. Let me tell you, they were interesting. Quite a few.
It's always ominous, Joe, and someone's like, "Oh, that's interesting."
Very interesting. Let's do this. Which method should we start with? Why don't we have a vote? What method do we want to see first? We got the math teacher proud way. We've got the scale, the visual scale. Cool. All right, cool. Let's do that. I'll start off with that one. Here's our scale, which I'll just tell you, I think is the second best way to do this problem. Here's our scale. What are we averaging on this one? That's always a big thing to set up our scale. We got to figure out what are the things we're averaging. So what are we averaging? Cards per day, cards per day. Good. So if you look up there, you notice we have 20 cards per day, 45 cards per day, 25 cards per day. Those are the averages that belong on our scale. So that's always the starting point. What is the thing we're averaging? Getting that pieced out. So for a few days, we're averaging 20. For some other days, we're averaging 45. And our overall average for all of these days is 25, which is closer to 20. So just sanity check. Can we eliminate any answers without going any further on this approach? Any answer choices that are out? Yeah, why A and B, I'd say. To eliminate anything more than that, we'd need to do some more calculations, but why are A and B like automatically out? Yeah. How many days were we at 45? Yeah, why? Remember 45, we had 2 days. And our average is closer to 20. So that means 20 has a greater weight than 45. You know, halfway between 20 and 45 is like 30 something. So we're close to 20. So 20 has a greater weight. So it's got to have more than 2 days at it. So we know we're more than 1 or 2. Gone. Cool. Yeah, it's because we knew 45 had 2 days. That's why. Exactly. Okay, so next up, let's get our differences. 20 to 25 is a difference of 5, just to kind of visualize what I'm doing there. And 25 to 45 is a difference of 20. And here we go. So we'll just make a ratio of the x days to 2 days. We flip our difference. It's going to be 20 to 5, which I'm going to reduce that. If you reduce 20 to 5, it's 4 to 1. So again, just flipping the difference. And our total number of days, not relevant on this problem, but just a good habit, would be 5. So that's our ratio of number of days. To actually figure out the number of days, though, it's not 4. We need to, this is just the relationship between the number of days. There are 4 times more days at first than days at 45 cars. How many days did we actually do it at 45 cars per day? Yeah, so the multiple of this ratio we want to equal things we know is not, wrong button. Is not 4 to 1 to 5. It's one where we know this second one has to be number 2, so it's going to be 8 to 2 to 10. That's the multiple of the ratio we want. So that's our answer, D. We're getting close to the clock.
Ooh, but I want to do the best way.
Okay.
I feel like you've gotten to do a lot of cool ways.
I think we've done enough teacher-approved ways. We can leave it to you guys as a challenge to set up that average times number of terms equals sum. Just remember to get your total sums and your total number of terms. Bit of a pain in the butt here because you've got variables in it, but you should get there in the end. Exactly. You got to multiply the whole ratio by something. So since the middle number needed to be 2, we had to multiply the whole ratio by 2. So it became 8 for the first one. All right, here comes the best way to do it.
Yay. I'm excited. Okay, so remember way back when we kept dropping like all these heavy foreshadowing hints about that distance from the average business? Well, we are going to come back to that, and that's going to help us here. So what do we know? Well, we know that our overall average is 25. And then we know that there are X days at 20, X days at 20. And then I have 2 days at 45. 2. So I'm going to think about how far each of these production rates is from my average. This is 5. Let's say this is -5. And then I'll say this is plus 20. So I know that for these, to get this average of 25, this is going to have to match up with this. It's going to have to balance out with this. So I have 2 times my plus 20 business, which means I have plus 40 on this side over here. So to balance that out, I'm going to have X times my -5 days, and that's going to have to balance out. That's going to have to equal -40. So it adds up to 0. So I can do X equals -40 over -5, and I get X equals 8. Oh man.
So
mix of delight and terror.
okay, so pretty crazy, huh, guys? Yeah, again, so this is something we talked about at the beginning. So this all stems from, and you can see how weighted averages, those concepts we talked about are kind of related to this same idea. The idea is if you know your overall average, your net difference has to be 0. And that's all we did here. Where the 45s ended up 40 above total. And so those 20s need to bring us 40 below. And we need 8 of them to get there. So
it did escalate quickly. And what I would say is if you like loved this distance from the average, use it. If this is super confusing for you, start with the long method. Start with the teacher approved method, sort of get that under your belt, and then start adding in these tricks. It's 40 because there's 2 of them.
Mm-hmm.
There's 2 45s.
Teacher approved. I'll show you the setup, and maybe we can leave to like a minute, like a quick bathroom break with the setup up there. Because
we want to make sure we have some time to get to verbal too.
Yeah. Here's the quick and dirty version of that. Average times number of terms equals the sum. For X days, that's the number of terms. We're averaging 20 cars, so that would give us a sum of 20X. For 2 days, we are averaging 45, so that gives us a sum of 90. I mean, on the whole, they told us our average is 25. To get our number of days, we just have to add them up. And to get our sum is 20, we have to add up our sums. So you would solve this equation for X. That looks really easy, by the way, what we just did. This to me is very hard. Setting this up correctly, getting everything in the right space, adding the correct things up. It's very challenging. But there it is. Okay, so what's next? Let's just see our takeaways here. Some things to remember from the day. Our latest one. Remember that idea of flipping the difference. You guys, some of you guys seem to be into it. I'd say if you got it, push it. Like if you just learned it today and never do it again for the next 2 weeks, you're not going to use it on test day. So if you think you got the hang of it, keep working on it, keep practicing it, come back to this stuff. Get it to a point where you can do it practically with your eyes closed. Don't forget. Yeah, if you just remember flip the difference, if that's the only thing you remember, then I don't know if that's going to have good results, but it is a good thing to remember.
Yep. And also that each of us will have a method that ends up working best for us. You know, you don't have to love all 3 of these, but you need at least one. And it's good to practice with more than one to build that flexibility.
Yeah, weighted averages is the topic we just covered.
Yep.
There's actually even a little more to weighted averages. There's a couple other little tricks, but we've shown you some of the biggest ones. Let's talk about prep options since you guys are clearly interested in it. I'll just say you're using the #1 best prep option, which is finding free stuff. Way to go. Bless you for that. Like, there's something free. I love resourceful people who can find that stuff and take advantage of it. So awesome. There's some other things though that are a little more comprehensive than 3 2-hour nights. So just want to show you what some of those are, and we'll come back to this. But we've made a little chart for you guys to look at tonight. Generally, I would look at the different options here, and then what's on the left are sort of the different advantages of each option. Good, I'd say budget plus people who are on more of a time crunch. I'd say the most comprehensive thing would be that standard complete course. But if your test is not more than 2 months away, if you're on a more of a tight deadline, that might be a deal killer. Or if you just don't have the time to make it to these things on a regular schedule. That said, the regular schedule can be nice. Interact is this amazing thing that Kat and me and one other instructor, Mary Richter, were a part of, as well as many other people. And that was just released, and I'll be humble and say it was amazing. It's a much better option, I think. Let me just give you a cheaper, a more budget option. Like, it's just lighter on the wallet. Just to give you a quick price, I think, let's see, 1 month is $250, but 6 months total is $399. So just 2 cups of coffee in Manhattan, or you could do Interact for 6 months. Anyway, it's basically these interactive videos. We're going to recommend these to you so you can get a feel for them, a free sort of a free sampling of them before session 2. So just keep that in the back of your mind. Very cool product.
All right. We're going to take just like a 1-minute break. If you need to get up, grab some water, go to the bathroom. When we come back in a minute, we are going to talk about a type of reading comp question. So we're going to do a little brief overview of reading comp, but we're going to focus in on this one specific question type in the remainder of tonight's session. Also, for people who have asked about the recordings of these sessions tonight, tomorrow, Thursday, they will be on our YouTube channel in about a week. So if you've missed things, you want to revisit things, you can come back to them when they're posted, and that should happen about a week from now.
All right, I'm gonna end this thing. If you guys have questions about what you're seeing here, let me know. But it's gone.
All right, we are going to now switch over to, we're going to switch over to verbal. And I'm just going to start you guys off with a question. So I'm going to give you 2 minutes to do this. Do what you can. We're going to talk about it. I'll launch a poll and you can poll in with your answer. All right, that is 2 minutes. Joe, what were the results of our poll like?
Good question. I have not deleted them. Let's take a look. Spiking around, little normal curve there around C.
Cool, but we got some people in every answer. This is going to be a good one to talk about. We're going to come back to this one, so don't worry if you thought it was hard. It is a hard problem. We're going to talk about it. But before we do, I want to set you guys up with a little information about what to expect from reading comp. So in this rest of tonight's session until 10, we're going to talk about what's in reading comp on the GRE. We're going to look at a standard process, the sort of teacher-approved proper way to do these types of questions, like the one you just did. They're called argument questions. And then we're going to do something very similar to what we did with weighted averages. We're going to look at how can we make these problems a little more efficient, a little easier? What tricks might help us manage some of the difficulty inherent in this type of problem? Because these are really hard. They're some of the hardest things in reading, which is why we're talking about them tonight. Okay. So what are you going to see on reading comp? Well, you're going to see 2 big categories of question. You're going to see questions that deal with content, and you're going to see questions that deal with logic. So content questions are going to ask you, what's the author's thesis? Why is it written, or this passage? Like, what is the structure of the passage? And those are going to be more of the reading questions that you see. Logic-based, which are the ones like the one you just did, are going to ask about reasoning, about how someone is getting to a conclusion based on a set of facts. For content-based, you'll see 3 different main types. For logic-based, you'll see a bunch of different types. There's a lot of little subtypes of these. We're going to talk about 2 tonight. We're going to talk about strengthen or weaken, ones that ask you to make a conclusion more or less likely, and ones that ask you to identify an assumption. And I'll talk a bunch about what those tasks entail, what that means. There are a few other types that you might see. So just to be prepared, you'll encounter these other types as you study, but we're not going to talk about these last three specifically tonight. So definitely some of the things we talk about will be applicable to these other types of logic-based questions. They're hard. Joe, why are they hard?
Yeah, good question. Really dense information, and that's just one thing they're going to do to intimidate us. They're going to be talking about a sulfur waste reduction plant or something like that, where you're like, I don't know about those. How am I supposed to answer this? I don't know. That's just what popped into my head right now. They are generally, at least some of these types of arguments are going to be by design bad arguments. They make a little bit of sense, but also sometimes they're bad enough that you're almost confused by what is the point they're even trying to make. So hard to understand the logic sometimes on these. One thing that you should be prepared for is, I think anyone who's prepared for any test in the past develops some sort of paranoia. I think it's sort of like from high school geometry. We remember, oh, a squared plus b squared equals c squared, and some of that's just like stuck in our heads for the rest of our lives, and nothing else. It's same thing with like if you've done any sort of test preparation, there's something about guessing B that I've heard people think is true. That's not true. But the other one is that new information is bad, and like extreme information is bad. On a lot of these argument question types, certain ones, and we'll see, as you saw, there's different types of kind of different tendencies. And a lot of these new facts are actually totally fine as long as they're relevant new facts. So be ready for that. You can get stuff out of left field and it can still be right. And they do sometimes get a little mathy with the logic on these.
Yeah. So if you're someone like me who's like so excited to get to verbal and relieved because we get to leave quant behind, these are maybe the slight bad news in reading comp that you do see, particularly statistics concepts showing up here. If you love quant, though, this could be your good news in reading, that you get to bring some of that type of thinking in. Bamboozled is a great word. In terms of the frequency of these questions, there's going to be 1 to 3 of them in each verbal section. So 2 to 6 total on the test, which is a significant question type. And you can spot them because they're really short. So when you get a really short passage that has just one question attached, you know immediately, boom, this is an argument question. So you immediately know how you're going to approach it. We've talked a little bit about this. It's very dense information, and it's a combination usually of facts and a conclusion. So we have a process for dealing with these, and I'm going to start you guys out today with our core sort of good teacher-approved process, and then we'll use this to build into some of the tricks that can help us do these more easily, faster. So the first thing I do when I see one of these is I look at the question. So before I read the passage here, I look at the question and I figure out what type of question is this, because that's going to tell me what the task I have in mind is when I read through my passage. Then I go back and I read through my passage. Now, for me, I don't take a ton of notes in verbal, except on these argument questions. I take a bunch of notes here because they're really dense. So I get that argument. I really understand it. And then I figure out, okay, what's going on here? What is my focus going to be when I look through my answer choices? Now, remember, Joe said my answer choices are often totally new facts. So I'm not trying to predict what that new fact might be, because it could be a lot of different things. I'm just getting some kind of focus. And what that focus might be, we'll see as we get more into these. And then finally, I use process of elimination. I think we'll see tonight, a lot of times it's easier to rule out wrong answers than it is necessarily to identify the right one. So we'll be looking a little bit at that as well. So let's try it. Let's walk through this process with a passage. All right. So we're going to start just with our question. So I grayed out the passage, so we're not focusing on that. We're looking at our question. And our question is asking us to weaken the conclusion that is given here. We're going to weaken that. What does that mean? What does that entail? So it's a strength and weaken question. For these, we get some premises, which we get are facts, and we get a conclusion. Joe, how would you describe the difference between those two things?
The way I think about this is, so our premise is these are the things we know, even if they're looking at them as a even if you doubt it, well, don't. The premise is a thing we know, and these are used to support this conclusion. And even that isn't the thing you necessarily doubt. What you want to doubt is that connection between them. So the premises support or try to support the conclusion, and we're meant to think about that connection between the two.
However, as Joe said, sometimes that connection is a little fuzzy, a little uncomfortable. These aren't good arguments. And it's usually because there's a lot of pieces missing. There's a big gap between those facts and that conclusion. That gap is filled in by assumptions. So things that have to be true for us to get to that conclusion, but that we're not saying. So if you ever look at one of these arguments and you're like, whoa, where did that conclusion come from? You'll probably have that experience. It's because this is happening, because these assumptions are there. So when we strengthen or weaken, we're looking to make that conclusion more or less likely to happen. So that's our task with this question that we're looking at. Keep that in the back of your mind. Let's quickly go through and look at what let's break down this argument that we have. Here we go. New methods of math education in this country do a disservice to our children. What do you guys think? Is this a premise or a fact, or is this a conclusion? Tell us in the chat. Is this first sentence a premise, a fact, or a conclusion? Is it something? Interesting. We're getting a mix. Yeah. I actually am starting you guys off with kind of a tricky one. This is actually a conclusion, but it's a little hard to spot. And I think that's why. Maybe we'll come back to why this is a conclusion in a second, but let's go on and look at our next sentence. Let's look at a couple facts, and then we'll come back and talk about why this one is a premise. Why this one is a conclusion. In the lower grades, so second sentence, math instruction should focus on the basic skills that students will need to solve complex problems in higher grades. What about the second sentence? Premise or conclusion? The premise. Yeah, nice. This one is a premise. Joe, how would you summarize this premise?
I would say they're saying that we need to get the basics early.
Nice. I like it. Cool. So we get the basics early. So then how is this different from our first sentence? They said that first sentence is actually a premise. Well, this second sentence is something that we're establishing. This is the way things are. Actually, let's keep going. We'll come back to that conclusion question. Next sentence. Learning math skills, basic math skills, is like learning the scales and chords that one will later use to master complicated concertos and symphonies. Premise or conclusion? Yep, we got another premise. So we have sort of an analogy with music. I'll just leave it at that. Won't get too into detail with that one. And then finally, last sentence, increasingly math educators in this country seem to have it backward, emphasizing in higher grades the same narrow skills-based approach that students learned in lower grades rather than the analytical tools that they will need to solve complex math problems. So that big last sentence, premise or conclusion? Yeah, premise is the word used for facts. It's a word used. We use premise because it's things that that person is taking, who's making the argument, is taking as a given, as a truth. It's not necessarily like in the world always 100% true in the way we think of a fact, but they're very closely aligned. And Joe, how would you summarize this last premise?
They're basically doing what we don't want them to do. They're doing. They're just teaching like basic ideas throughout. They never learn analytical tools.
Cool. So let's think about our facts. We have children get the basics, should get the basics early. There's an analogy with music education. And then we're saying, but math educators aren't doing what we want them to do. And that then interestingly circles back to our opening, that first sentence, which is what all of these facts add up to. Saying, this is our assertion. We believe that math ed is bad. So that's our conclusion. It's the thing that we are building to with these facts, but it doesn't necessarily come at the end. I think that's what makes this so tricky. Our conclusion is actually up front, and it's once we've picked through the passage that we see that this is the conclusion, that this is the summation of where we're going. This is exhausting though, right? This is a really slow, drawn out process. So we're going to get to a point where we're able to find some faster ways to do this. Yeah, and Althea, I agree. This is poorly written, and that's actually a common problem with a lot of these GRE questions. They're not amazingly written, and we have to deal with this. All right.
So I'll just add one thing is like, where is that conclusion? And the one weird thing is conclusion is not, just to differentiate, conclusion is not like a conclusion to a 5-paragraph essay where it's the summary, like restating things. When we say conclusion, we mean the thing that's being supported or the thing we're trying to prove. There will only be one ultimate conclusion in a passage, and it can occur anywhere. We could say the thing we believe and then support it, or we could give a bunch of evidence and then wrap it all up with like, and so therefore we believe this thing. So it can happen anywhere, but it's the thing we believe and that we're trying to prove, or that the writer is trying to prove.
Nice. And Brittany, I do that. I do that when I write. I label like P and C for premise and conclusion. I think that can be a good thing to do for sure. And you take notes. So we want to weaken this conclusion. We want to make it less likely that these math education methods are doing a disservice. That's our goal. We're looking for a fact that's going to make this conclusion we've identified less likely. So keeping that in mind, let's go and see what we have with our answers. I'll give you guys a moment to read, a minute or so to read through these, and then we'll launch a poll and see what you guys think. All right, that's about a minute. Give us your best. If you had to just guess now, I'm giving you guys pretty strict timing just for the sake of our overall time tonight. But that was relatively fast. Cool. It looks a lot of people are focusing on B. We do have a clear winner. Why B? Why did you choose B? How did B seem to undermine our conclusion? How would you explain that? So B is saying on international tests of complex math skills, high school students in this country performed no worse than did their counterparts from countries in which problem solving is emphasized in higher grades. So they're comparing to countries that have a different method, but they're saying that different method doesn't produce better results. So if we're trying to make it less likely that we're doing a disservice to our children, saying that doing it differently doesn't produce better results, well, that's also saying maybe our system isn't so bad after all. Yeah, there's some tricks here. And Joe's going to talk through those really quickly, how our wrong answers are maybe trying to throw us off, or why A, C, D, and E are going to lead us astray.
Yeah, so I'm going to just start with the giveaway here. Is this full approach is we're showing you how we want you to think about this, but there's a reality of like this is on a time test. We got to be willing to just get there as fast as we can sometimes, and do this as best we can in a shorter amount of time. So let me just show you how far you can get just with one idea, and that's understanding the conclusion. So let's just look at these wrong answers. What if all I really knew here was what the conclusion was, and I just kind of had the gist of the rest? So I knew that the new methods of math education in the country do a disservice to our children, blah, 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 blah. And I know I want to weaken that. So I want to say that I want something that's weakening this idea that new methods are a disservice, or I want something that maybe the new methods aren't so bad. If I have that direction, let's look at our answers. Music courses are often included in elementary school curricula. Such classes are rarely taught in high school. I don't care about music courses. I want to know if my math education is good or not. I don't care about music. When presented with math problem to solve, students in higher grades are more likely to arrive at different answers than students at lower grades. That's at least talking about math, but why do I care about different answers versus like, are they more right or wrong? I want to know if it's good education, not if they have different answers. C would require more jumps to get to. D, older students tend to receive higher grades in math than younger students do. Okay, so what does that mean? Is our education good or bad? Are they getting F's and E's? Like those older students are so much better. I want to know if we're having good education, or if our new methods will do well, and D speaks nothing to that. And E is tricky. I might fall for E as a trap if I'm in a hurry here, but ultimately we don't know, are these universities getting an increase in first-year students from our country? Are these students who had math education in our country? So ultimately that makes it irrelevant to our question. So just knowing that conclusion, direction, and talking about the right stuff.
Yeah, I think, is anyone else having some trouble hearing Joe? I think I am.
Yeah, I had a
Yeah.
momentary lapse there.
Sorry. But yeah, what Joe is saying, and that's going to come to our first sort of tip to making these faster, is focusing on that conclusion can help you do these. So we walked through that process and it works, but it was really labor intensive and time intensive. I also thought that the problem was on my end, so I waited for a moment. But there's going to be a better way. There's a couple other things that might help, which hopefully we'll have time to touch on, but I do want to start on this focus on the conclusion one because it's going to be really useful. So let's come back to that wheat prices problem that was so hard in the beginning. Yes, B was the correct answer for that last one. Here is that same problem. You've seen this passage before. It was quite tricky. And what I want you guys to do is I want you to just take a minute, and everyone do this, summarize the conclusion of this passage in your own words. If your first name begins with the letter A through D, go ahead and share that summary in the chat. So find the conclusion, summarize it in your own words. A through D, share that summary in the chat. I'll give you about a minute to do it. All right. Cool. I'm seeing lots of summaries here. People are touching on a lot of the components of this. Now, one of the things that makes this a really tricky problem is that the conclusion kind of comes in two parts. I get that the US farm subsidies are lowering the price of wheat. That's one of the sort of claims that's actually going to lead up to our conclusion, and that's what I'm seeing in a lot of the paraphrasings people are sharing. But then I get this at the end. Without these subsidies, American farmers would produce only the amount of wheat that they could sell on the open market, and the global price of wheat would rise. So if I were going to summarize this conclusion, I would actually say something like no US subsidies. It would be less US wheat, global price rise. Something along those lines. I want to get all of those pieces in the ultimate thing I'm building up to. Like Joe was saying, the conclusion is the thing that all of our steps are summed up by. And that final sentence is where we get that overall thing, that the global price of wheat is going to rise if I get rid of these subsidies. That's my overall claim. Okay, so now let's take a look. Here, we're just going to focus on the conclusion now. We're going to come back to our answer choices, and I'm only going to give you this conclusion, the idea that no subsidies equals higher price of wheat. I'll put that up here too. No subsidies equals higher price of wheat. And so I'm just going to keep that conclusion in mind as I evaluate my answer choices. So let's actually take a moment. We're looking to weaken this, right? So we're looking to make it less likely that the price of wheat will rise. Less likely that the price of wheat will rise. Joe will launch the poll. I'll give you another minute just focusing on this conclusion. Which of these answer choices most undermines it? Reevaluate your thinking on this. And then let's see what our poll results are. What is the magical tip 3? Will we ever know? Not if Joe has his way. Joe, what are our poll results? What are you seeing?
There we go. Focusing on C and E with some D's and a smattering of other answers.
All right. So let's say we'll get rid of A and B. Because if we're thinking, okay, this has to do with the global price of wheat rising. This is industrial applications. It's kind of out of the focus of that. And the same with non-governmental buyers predicting. Doesn't necessarily tell us anything about the price of wheat. So if I'm just thinking lightning focus on that conclusion, let's get rid of these. C is one that Joe is actually very tempted by when we talked through this problem. Joe, do you want to tell us about why you were into C originally?
Well, yeah, it's like, come on, soybean farmers, it's the same idea. Why couldn't it be relevant? And I think the answer is it could be, but they would need to spell it out for us. We're not meant to know if like soybeans are a good proxy for wheat. That's not meant like a common knowledge thing. Like, oh yeah, wheat should behave like soybeans. So they would have to spell that out a little more for us. Like soybeans,
soybeans,
blah blah blah.
Yeah, a crop very similar to wheat. Yep, and the same thing is true of E. again, maybe this could, if I knew that sorghum behaved similarly to wheat, or there were similar things going on with sorghum, if they spelled that out for me, maybe it would influence it. But I don't know that for sure. And then Naya made a really great point, global price. So at first glance, we might want to rule out D, right? Because it says other countries, but then we remember, global price. So if the global price is going to rise, does D impact that? Yeah. If other countries are producing more wheat, well, that's going to undo the effect of the US producing less. Yeah. So C again is saying that it's giving an example about soybeans that seems to have a similar logic, but we don't know that soybeans behave like wheat. Wheat could be totally different. Yeah, these are really hard. These are some of the hardest, and these are hard versions of an already hard question type. We're challenging you guys with some really tough stuff tonight. Something to take away from this problem, I think, is that we can get to the right answer without having to regard all of that other text. You know, we can kind of go through that quickly, hone in, have a lightning focus on this conclusion when we see that it's a strengthened, weakened question. And it weakens this conclusion. Yeah, it does at first glance feel like it's unrelated. I do think that that's part of the trick here. So what it's saying, basically, I'll walk through the logic one more time because it's a tricky problem. So our conclusion is saying the US, if the US produces more, then say, okay, US makes more, or sorry, the US makes less, prices rise. But what D is saying, like US makes less, other countries make more. Then that's going to equal, so D is saying that's going to equal price doesn't rise. So that's what D is saying. It's giving us something that's going to directly undercut the idea that the price of wheat is going to rise. And if I focus on that conclusion, I think it makes it easier to get to D. Actually focusing a lot on the other facts in this argument could make this one trickier, but it is a very hard question. So one of our top, probably our top tips is, so this first part here is the conclusion. The second part is what D is doing. So the part in pink is what the conclusion is. The part underneath it is what D is doing.
As we head into our next bit, I'll just point out and see another way you could eliminate it. Is they're saying that we do similar things to soybean and the price is higher than wheat. It doesn't say that they did things similar to the soybeans and the price went up or down. And that's what we're trying to figure out about wheat is, will the price go up or down? How is it going to change? And this is just making a comparison for how does soybean compare to wheat. It's possible soybean's higher, but when the US government did this, it went up or it went down, we don't know. So the comparison of soybean price to wheat price is not what we want. We want to know what will happen to wheat when we make this change, which leads us into our next topic.
Yeah. Exactly. Common flaws. Being aware of common types of errors and patterns that these arguments make can really help us to do these faster. So really quick, we want to show you with some simpler sentences, some of the common types of flaws that you might see on the test. So here's one. The majority of bricks used in this building are old. Therefore, there are many old bricks in this building. What is wrong with this? If someone told you this statement, how would you say, no, you're wrong? How would you argue against them? What is this person doing? The majority of bricks used in this building are old. Therefore, nice. Yeah, you guys are getting it. So this is equating a proportion, majority, a proportion is not an amount. So just because I know that most of the bricks are old, it doesn't mean that I know that a lot of bricks, there are a lot of bricks in general. I could have only 5 bricks in the building. So the majority would be 3 and it would be a small amount. What about this? Each brick in this building is old. Therefore, the brick parts of this building are older than the other parts of the building. Nice. Yeah. Yeah. So this is, you guys are getting it. Nice. Saying sort of an absolute doesn't equal a comparison. So just because things are old, I don't know how they relate in terms of age to other things there. And vice versa. If I give you a comparison, I don't know absolute. So I could say this is older than that, but that doesn't mean that it's old. And then we have a third one. Joe, what about this one?
So this one, yeah, take a second, read it. If you guys can name it. Yeah. Nicely done, Kat. Love it. Yeah, they're saying, hey, the bricks are older and it collapsed. So the old bricks must have caused the collapse. This is touching on the idea of correlation versus causation, which is just fancy talk for just because something is two things are in the same place doesn't mean that one of them caused the other to happen, or we don't know which one caused the other. If I pick up a rock and win the lottery, that doesn't mean picking up the rock caused me to win the lottery. It's just two things that happen potentially.
Cool. Joe, do you think we have time to do one more problem?
Let's, yeah, I do. Let's point out, because we have an assignment for you, and just in case people got to go, let's give them what that assignment's going to be.
Yeah.
So I'm going to give you guys this link here. Go ahead and keep it. You could also just Google this. It's just GRE Interact. But here's a link to it if you need it, if you don't know how to use Google. Yeah, you have some homework. There's a 7-day free trial at that link. So we're going to ask all you guys to get your 7-day free trial. Don't worry, I'm not trying to zing you. Just get your 7 days. That gives you access to about a quarter of the lessons we offer. There's quant and verbal ones, these really cool interactive lessons. We want you to watch lessons 10, which is on quantitative comparisons, and 15, which is on sentence equivalence. So, oop, I private chatted it to you. Let me try again. Okay, watch 10 and 15, QC and SE. Just there's a link on that page that says 7-day free trial. And it should be pretty simple from there. Okay, so we're going to do one more problem for you guys if you want to stick around.
It's just going to take me a sec to get us there.
So that is your homework for tomorrow. So we're going to push on that stuff tomorrow. That's in that 7-day free trial at the link I just sent. Kurti. Yeah, look around to the page. You'll find it. It's there. It's a little link. Cool.
All right, so here's our last problem. And I am curious. I want to start before I give you the answers. What is the flaw here? We showed you a few different types of flaws that you might see. What's the flaw in this argument? So I'll give you a minute to read it and then tell us what in the chat, what kind of flaw are you seeing? Yeah, it's true. We don't know that it will continue to increase. Yeah, there's something there, Jessica. We don't know where the starting point is. Yeah. So we don't know if it's going to continue to increase. Do we know if they're already using a lot of power? Like, do we know anything about the amount of power that's being used? Yeah, we don't know anything about trends. Yeah, we don't know how much. So this is the one that we saw on the previous page with the many bricks versus the or sorry, no, it was the second one with the old and older. It's giving us an increase, but that's not necessarily the same. So it's increase, but we don't know quantity. That's the flaw. Yep, we don't know. Oh, nice, Caroline. Yeah, we don't know how the actual amount compares to what our current capacity is. So we're gonna take that. We're gonna, now that we've identified that flaw, we're gonna keep it in mind. So the flaw says, okay, it's changing, it's increasing, but maybe we don't actually use that much. Maybe we use a lot. We don't know how much. So if we're saying that we're going to then decrease the total amount of power, we're assuming, this is going to be an assumption question, we're assuming that that there is actually a lot of power being used, but we don't know for certain how much power is being used. We just know that it's increasing. Yeah. Yeah, that's sort of the problem, Radhanath, with this argument, that this person is assuming we're going to need that more space, but maybe we don't actually. Remember, these are going to be flawed arguments. So here's our last set of answers for the night. This is going to be our last poll. We'll give you a minute. Keep that flaw in mind. If you have to go, thanks for joining. Hope to see you back tomorrow, Thursday. Keep that flaw in mind. Joe's going to launch a poll. Joe, what do our answers look like?
They're quite exciting.
Ooh, strong preference for A. I love it because A is the right answer. Yes, that is it. That's hitting on our question of amount, right? A is saying, okay, this person is saying we need to increase demand. Well, they're assuming that we can't just already, we need to increase production, but they're assuming we can't just already meet production. This is that common flaw, and knowing that common flaw can help us spot A really fast. Awesome work, guys. Yay. I'm glad that we got to A on this one. That made me happy. Thank you so much. I'm sorry we don't have more time to talk about more flaws. There's tons of these common flaws. Keep an eye out for them as you study. Thanks for sticking around to do this last question. Have an awesome night. We'll be back here same time, same place tomorrow night to talk about some different stuff. Hope to see you then. If not, good luck in your studies. Have a great night.
See you on the internet again tomorrow, guys. It's been real. Classes are 3 hours. These are 2 hours per evening.
The recording won't be up on YouTube for about another week or so, and we'll send out an email blast to everyone when the YouTube link is available.
And no one else had video or audio, Jessica. So there's no video or audio to have recorded. Just us.
To answer a question I just saw float by, paid classes are 3 hours long. They're one teacher only. and they're much, much smaller. So they're much, much more interactive and student-centered than this was. This was a bit of a change for us.
Paid classes are in the same format on this sort of Zoom format. They're online like this, but there's a cap of 15 people and there's one instructor. So yeah, a lot more individual attention.
And everyone is on video, so it does feel a lot more like an in-person course would. Yeah. Starts the same time tomorrow at 8 p.m. And it is 2 hours long. You guys are all really welcome. Thanks for coming.
7 weeks. Alex, I'd say it's going to depend on your budget, but I think try that Interact free trial. See if it's to your liking. I think that's a good self-paced program, a really good one. So check out the free trial, see if you're liking that. I think that's a good place to start searching. If you're more of a book learner, then I think a set of books could be helpful.
It would be 7 p.m. Tomorrow night. Yes, there is homework in Interact. It includes, it's a one everything you need package. So there's tons of drills, there's tons of problem sets. It's all organized and distributed across the lessons. It comes with practice tests. So it's designed to be a complete comprehensive thing.
What's 7? Wait, I think 8 p.m. tomorrow.
Kat, you should definitely come on Thursday. Each of these sessions is designed to stand alone. So you won't feel out of sync if you come on Thursday. And then if you're here, you can ask questions and participate. So it'll be more fun than watching a recording. Yes, 8 p.m. Eastern tomorrow night. All right, we are going to close out the room. We're going to sign off, but we will be back tomorrow night and we'll see hopefully a lot of you there.
Bye, everyone.